Hello everyone, and thank you for attending today's webinar on 4.9G and 5G private wireless networks accelerating digital transformation across industries, sponsored by DoubleRadius and Nokia. Before we begin, I would like to cover some housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck will be available for download in the green resource list widget. Towards the end of today's presentation, please complete the survey on the right-hand side of your screen. It will only take 1 minute to complete, and your feedback is extremely helpful. An on-demand version of this webcast will be available about 1 day after the event, and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading's Principal Analyst, Gabriel Brown.
Thank you, James, and hello, everybody. Welcome to today's session on private wireless networks. It's terrific to have you with us. Thank you for coming. Private mobile is, of course, an important topic in the wireless networking industry. There's great interest in the technology itself, of course. And from the enterprise point of view, the focus is really on how these networks can help deliver the performance that enable new operating processes to increase productivity, resiliency, safety, or all three of those things. So in the webinar today, we'll discuss how this technology is applicable to many diverse industries, from manufacturing, utilities, transportation, public sector. If I didn't mention your sector there, I see we've got a good range of people logged in on the call today. It's a horizontal platform, really, in that sense, so stay with us. We'll look at the different types of private wireless solutions that can be deployed to create local area and campus area network. As you scale up, you get into field area, potentially an area to discuss as well. And then we'll look at how 4.9G and 5G private wireless technology meets the demands of Industry 4.0. That's the industry automation play. My name is Gabriel Brown. I'm Principal Analyst with Heavy Reading, where I cover mobile network services. I will be your moderator for today. I'm joined by three terrific guest speakers. I'm going to ask each of them to introduce themselves before we go to the agenda. So first of all, I'd like to welcome Katie Hale from DoubleRadius, where she's Director of Business Development. Welcome, Katie. Great to have you on the call. Could you say a few words?
Yeah, thanks, Gabriel. Great to be here today. I'm the Director of Business Development at DoubleRadius, and I manage a lot of our current vendors and new vendors that we want to partner with to help bring, new products and services to our customers. We mostly focus on the wireless internet service providers market. So we're always looking for new products and solutions to build an end-to-end solution for them. So thanks for having us today.
Terrific. Thank you, Katie. Then we have your colleague, Jerry Ford, who's president of DoubleRadius. Welcome, Jerry.
Hey, thank you, Gabriel. Gary Ford here. Been with DoubleRadius for a good while. We're a 22-year-old North American distributor with offices in Charlotte, North Carolina, Salt Lake City, and Toronto, Canada. So we're excited to be here.
Good stuff. Thank you. And now we have Mark Brandt. He's head of North American manufacturing, logistics, and retail for Nokia. A lot of experience in the private wireless market. Welcome, Mark. Want to tell us a bit about your background and what you're doing? I believe you're on mute.
Yes, thank you, Gabriel, and thank you for the DoubleRadius team for participating in this webinar. So as I head up a sales enablement team that's focused on the industrial sectors with Nokia, and so we work alongside our sales team. I have a background from the enterprise side. I spent many decades in the enterprise side of the house doing wireless networks. So 21 years at FedEx, where I was the chief engineer in the wireless networking group, and then left that to come over to Nokia. And so we're seeing lots of excitement in the industry around these private wireless networks, and we look forward to being able to share that with the audience today.
Terrific. Thank you, Mark. Great to have you. Obviously, Mark's going to be sharing Nokia's perspective, but also has the practitioner's background as well, which is great to have. Before we move on, just quickly, all speakers are really open to taking questions. You can submit at any time as we go through via the Q&A box on your screen. I know it is quite small and you have to fiddle a bit to get your question in, but we are looking and we will keep an eye on it and try and put them to questions, put them to the speakers in the Q&A section. So please take advantage of that. I know they're really open to taking questions, so you are welcome. So in terms of the agenda, I'm going to give it the shortest introduction. We'll then hear from DoubleRadius. That's actually Katie who will run through that section. Gary will join us for the Q&A at the end, where she'll discuss partnering and the role that plays before Mark at Nokia takes us, I guess, through the bulk of the material on how to build industrial-grade private wireless systems. So with that, just in terms of a really quick background, I think we know now sort of pretty well why private mobile networks are interesting. It's generally about coverage. You have an area with no or limited public network coverage. Very classically, things like remote mining or remote primary industry type applications. But also indoors, for example, inside a warehouse or these kinds of areas where you don't get a public network service. We think when you have performance requirements that are not achievable necessarily on Wi-Fi, for example, if you have a requirement for high-speed mobility, device density, or where you take advantage of some of the kind of cellular system attributes, the scheduled access, the low latency, the QoS, and these types of things that come out. Now, Wi-Fi, of course, is getting better all the time, so the point at where these two cross over is something that we need to keep a kind of a constant eye on as well. Network control is very important. If you need a configuration that you wouldn't be able to support on a public network, which is optimized for smartphones and downlink traffic, well, in many private scenarios, you may need to optimize for uplink, or if you're dealing with production critical processes, you need a different failover mode. You can't really be failing over to a neighboring cell and making do for a week or something like that. You really need a different model. So you'd have, for example, multi-TRPs, for example, in a really high reliability scenario. And then, of course, security and privacy. It's really just keeping your data in your hands. I think the key thing right now is that partly there is a lot of hype around this. Hype's not quite the word. There's a lot of interest, and some of that is a technology seeking a market. There's no doubt about it. But really, fundamentally, the reason why we're seeing all this activity is because of the way that high-performance mobile connectivity matched with edge cloud infrastructure can enable new OT and IT applications. Really, it's part of an end-to-end process. It's not just the private mobile connectivity on its own, but it's as part of an end-to-end transformation process, it can have a big impact on business operations. As an industry now, there are increasing number of systems available, and actually a really diverse set of examples in different geographies, different frequency bands, different kind of applications that people are running on them, that we can be really, I would say, very confident in how these are going to perform in any given sort of situation. So with that, I'm going to hand over to Katie at DoubleRadius to take us through the next section. Katie, please, the controls are yours.
Awesome. Thanks, Gabriel. Appreciate the introduction. So DoubleRadius, is really happy to be here today. So thanks again for having us. For those of you who may not know who DoubleRadius is, I'm going to do a quick introduction of ourselves. So DoubleRadius, we're a value-added telecommunications distributor that's headquartered in Charlotte, North Carolina. We also have facilities and warehouse facilities in Salt Lake City, Utah, and Toronto, Canada. So we cover all of North America. We've been in the industry for over 20 years, and primarily we were focused on fixed wireless access and really growing Tier 3 and Tier 4 wireless internet service providers. And many of our customers really have relied on our experience and knowledge to design and build the best wireless network for themselves or for them. We offer on-site training and certification in our Charlotte training facility, really multiple times a month. And then we also will go out on customer sites if needed and do training and certify their installers and their staff as well. We have a full staff of engineers who do pre-sales configurations and consulting. They'll also do RF designs and site surveys, and then they also can do integration installation. So it's just some of the benefits that we bring to the table for our customers and what we've been doing for the past 20 years. And really at DoubleRadius, we try to focus on all things wireless. So whether it's point-to-point wireless backhaul, microwave links, or indoor WLAN, or even now private LTE in CBRS. We really try, that's kind of our sweet spot for DoubleRadius. And really our purpose is to be our customers' really trusted partner, and we feel like we do a really good job at that, and that's why we've been successful so successful in this industry with the wireless tier 3 and tier 4 service providers, and it really also ties to our lengthy experience in being in this industry. So we also we recently have helped a lot of our customers design and build private networks, especially because CBRS opened about 2 years ago. I think it'll be 2 years this October, opening CBRS in the US. So this really has prompted a lot of service providers to want to build private wireless networks. It also, CBRS has really led us into going into new markets and new deployments like campus connectivity, warehouse connectivity, and small to medium municipalities and other enterprise deployments. And we're able to support these projects because of our experience for the past 20 years and really the partnerships that we have made. And speaking of those partnerships, we try to partner with some of the best manufacturers in the industry to give our customers the best products for their networks. And this is one of the big reasons why we wanted to partner with Nokia, and we're here today with Nokia, is, we want to give our service providers and enterprise organizations the most secure and resilient private network offerings for their deployments. And we also want to give our customers an end-to-end solution, which Nokia has a great end-to-end solution. Their product offering is comprehensive, from licensed microwave and their modular private wireless and their NDAC cloud solution to their MPLS and fiber to the home. It has really allowed us at DoubleRadius to expand our offerings to our customers and give them the best options when building out their networks. Nokia's security and resilience also gives our customers peace of mind when building out a private network, and we know how much that means to our customers. It needs to be secure, it needs to be resilient, and Nokia really offers that. And lastly, we truly feel that Nokia's core values and the attention they give to their customers is unmatched in the industry, and it aligns with our commitment to our customers. They've been really a great partner to work with, and we're looking forward to introducing Nokia to more of our customers in the future. And we're glad to have them here with us today and partnering with us for this webinar for you all. And on that note, I'm going to introduce Mark Brandt, who is the head of the North American industrial sectors for Nokia, and he'll be introducing Nokia's private grade wireless solution to you all. Thanks for being with us today, Mark.
All right, well, thank you, Katie, for the introduction there. Again, we're here today to talk about how these private wireless networks are being rapidly adopted within the different verticals, including what I call the industrial verticals, manufacturing, logistics, and others. So with that, we'll take a look at why are these networks becoming the topic of the conversation? Why are they being rapidly adopted by these industries? So if we look at these industries and the choices that they have had for wireless connectivity in their facilities and within their buildings and on their premises, for up until the advent of private wireless, there was really two choices that they had here. They could either use Wi-Fi or they could use public cellular. Now, both of those technologies are great for what they were originally intended to be used for. But when you try to push them into the industrial space with its environmental conditions, then you'll see some issues around that. So Wi-Fi was excellent for what it was designed for, and that was the home and the office environment, and primarily, where things didn't move faster than walking speed, and you had a carpeted environment or acoustic tiled ceilings, and you had these soft surroundings on the walls and things that reduced the amount of reflected radio signals that can be problematic for Wi-Fi. So when you put Wi-Fi in that industrial environment, you have hard concrete floors, metal deck ceilings that are 40 feet high, and all the metal racking and tools and machinery and things that you encounter in these environments. It becomes very difficult and challenging for Wi-Fi because it doesn't deal well with those reflected signals, because it was never intended to be used as what we call a mobility wireless protocol. Whereas public cellular, on the other hand, was developed as a wireless mobility protocol. So it in and of itself works fine in the industrial environment, but it has some other challenges associated with it in those environments. First of all, coverage. So if you have coverage inside your facility, great. But if you don't, then you get the honor of building the carrier's network infrastructure out inside your facility on your CapEx dollars, and then connecting it to the carrier's network using your OpEx dollars, all for the privilege of buying data from them by the byte. And so that doesn't equate to a real good value proposition for building coverage out. But even if you did have coverage, there's still a problem with latency. Since you have no control over the number of users that are attached to any particular cell site, and in particular the cell site that's serving your facility, then latency becomes an issue, and it can be all over the board. So, Wi-Fi, great for what it was designed for, works great in the office and carpeted environments, but struggles in these industrial environments. In public cellular, because of latency issues and coverage issues, it also can struggle in these environments. So that's the reason that these 5G and LTE networks have, or people are flocking to adopt to them. And why are they the answer? So I refer to it as what I call the 3 C's. If you can control the coverage specific to your facility in every nook and cranny that operations technology needs it, and you can design the capacity of the network to accommodate the load you're presenting to it. And since it's a private network, the only users are going to be users that you allow on the network, and you know what applications they're running and what those data requirements for the applications are, so that you can design the capacity accordingly. So control of the network is also a big factor. So being able to control the network configuration, device configurations, who's on the network, all that comes into play. And so if you want predictable results with mathematical certainty, and you control these 3 C's, then it is certainty what you're going to get for a result. And in my opinion, the most important is latency. It's steady and definable. You get to design that into your solution and create a latency window that fits within what your application servers are requiring. So my own personal experience is if you can keep latency at under 100 milliseconds, then most application servers will be happy with that. When you routinely go beyond that and spend a lot of time beyond that 100 milliseconds, then those application servers start to have issues, performance issues, and your latency goes up and your reliability goes down. So those are some of the reasons why industry has been adopting these private wireless networks. It's the right technology with the right amount of control to solve their problems. So why Nokia? Well, as the DoubleRadius team referred to, we have this extensive portfolio of products and services, everywhere from the endpoints to the application layer. So we have handhelds and tablets that are industrial ruggedized devices that operate on these private networks, along with industrial dongles for connecting things like forklifts or cameras or machines or other things, along with vehicular routers with multiple IP addressing and industrial layer 3 switches that are wireless enabled to pick up a lot of legacy industry solutions. Those endpoints connect to our radio portfolio, and Nokia has long enjoyed a reputation as the premier provider of small cells, where we have several models of radio to choose from in the enterprise environment that enable these endpoints to connect up to the radio, and then coupled with our transport options with our mission critical IP and optical networks, as well as backhaul with our microwave and passive optical LAN products, give versatility in the backhaul and transport space. We manufacture our own core, and oftentimes on large deployments, we manufacture our own servers that those cores run on, along with all the apps and edge services and cloud management options and things. Gives the end user and the end enterprise a single end-to-end solution that is orchestrated and managed from a single pane of glass, and allowing you to have all kinds of versatility. So with that, let's talk about for a minute, what are these private LTE and 5G networks? What do they look like? So I'm going to show a simple diagram of the lowest scale deployment that one of these networks might take. And this is Nokia's approach to how we solve this problem. So within the facility, we deploy at a minimum 3 network elements onto the customer's premise. And so that would consist of an edge server. We call it the Nokia Edge Server, that would run the core network required for LTE and 5G networking, as well as a base station radio, or access point, if you will, because that's a term more familiar to the enterprise. And then we provide a firewall router switch to be able to configure our network elements and make them available. With that approach, by putting that core network on site, then the end user devices, all of their data stays local to the facility or local to the enterprise network. Now, it can go out to the internet if that's where its application server resides in a public cloud or something, or it's not preventing it from doing that. But the point is, it's not required to go there. So your data can stay local, and therefore it stays secure. Now, we provide a private cloud to manage this solution with. So the Nokia Digital Automation Cloud's managed by Nokia, and we create a customer portal that allows you to log in, and then based on what your credentials are on login, say you're just have view only access, you can see the status of the network elements and the performance of them, as well as the status of any individual end user device, and what their aggregate throughputs and things are, all the way up to being able to manage the network portion of it, creating new VLANs, new network configurations, as well as understand the analytics and having a dashboard view of all that. So when deployed this way, it becomes simple, plug and play. The user data stays local, and therefore it's secure. You have complete configuration control, which all that results in a reliable, high-performance wireless network that's suitable for mission-critical use cases in these industrial environments. And the kicker at the end of all this is it's typically at a much lower cost to deploy than Wi-Fi. And so we'll take a look at that towards a little bit later in the presentation. So with that edge server that we deploy, it brings a lot of power to the premise. So the edge server runs our network core, but it also provides a venue, a private cloud, if you will, to be able to run other applications. So in its most basic form, this network configuration provides you connectivity. I can't say enough about how important connectivity is to any kind of Industry 4.0 or digital transformation journey that these enterprises may be embarking on. Rock solid connectivity forms the foundation for which all other use cases are built upon. And all the ROI and the efficiency gains and everything depend on those use cases being able to run reliably. So we like to say private wireless is the foundation. I'll take it a step further and say it's the cornerstone of the foundation. It's built on bedrock out of solid granite. So this is very reliable operations from these wireless networks. So with that basic connectivity, you can then start adding applications and use cases. And so from that portal login, you can browse through Nokia's catalog of applications and push them down to your particular site. One popular such application is what we call Team Comms. And this gives end user devices push to talk, push to video capability for individual calls or group calls, much like a Microsoft Teams meeting that you would be able to engage in. There's also other plugins that are available, such as we have cloud connectors for all the popular public cloud offerings that facilitates easy access to those clouds, as well as industrial connectors for some of the industrial protocols such as Modbus or Profinet, and Scene Analytics and others. But in addition to the Nokia supplied applications, we also accommodate third-party applications. So the enterprise's developed applications or third-party applications that they may be running. Maybe they want the benefits of that public cloud, but recognize some of the security and latency and reliability issues associated with that. Well, they can push those applications down through this Nokia cloud-based approach, management-based approach, and deploy them locally on-prem. So now you get the benefits of the public cloud with the performance and reliability of on-site operations. So it makes for a powerful tool to enable these digital transformation journeys. So let's take a look specifically at the manufacturing realm. Now here we're showing a picture of a process, petrochemical manufacturing facility. Going into the steel inside this these very dense environments is very difficult and a harsh environment. Where LTE and 5G thrive in this environment. They work very well. They can accommodate the reflected signals. The reflected signals they see actually aid and assist the coverage, whereas in Wi-Fi, it's more like destructive interference and it causes confusion. You get real good performance in these types of environments. And so the performance to run use cases that you would see in that are typically across many of the different verticals. This is not just limited to manufacturing, logistics, or even retail, but across a broad spectrum of the verticals that are out there. So these are some of the early adoption use cases you see deployed all across the landscape. Video is very important use case. So previously, like on Wi-Fi networks, it was difficult to run video because a single camera running a steady uplink stream would consume a Wi-Fi access point where no other users could get onto that access point. So you don't see a whole lot of those deployed in the Wi-Fi environment. Whereas with LTE or 5G, you can run many cameras on it and still have other applications running through there because of the way they can accommodate multiple users simultaneously. So if you're wanting for like security cameras, you'll have cameras where they're easy to deploy them with copper or fiber connections. But if you wanted a view of your facility from like the perimeter looking back in to get that strategic situational awareness, running a fiber out there, trenching across the parking lot and running it out to a pole on the perimeter becomes cost prohibitive, so you don't typically see that done. But with a wireless connection back to the network, you take that out of play and it becomes real easy to deploy those. So you got a lot of versatility with how you can deploy cameras. In addition, video is important in the manufacturing process. You'll see cases where a camera monitors something rolling down the assembly line. Let's say it's an automobile manufacturing facility, and the camera is looking at how the fit is between the fenders and the doors and the various body parts. Well, using scene analytics technology alongside the camera image, you're able to detect if there's any misalignment or other anomalies that may occur and trigger warnings and be able to, adjust things as necessary. So video is a great use case. But in addition, all the assets that you deploy in these facilities, if you look at the, like robotic arms or machines and other controllers and things that are part of your assets that you deploy, you want those assets up and running all the time. You want to have that reliability to where they're up. You're maximizing the uptime so that you can monetize those investments that you made for the assets. So that's typically been done with either fiber or copper because that was deemed reliable enough. Well, and with these private wireless networks, they are reliable enough to connect those type of assets to the network. And by doing so, it gives you the versatility to make moves, adds, and changes to your production floor with minimal impact. For instance, if you're you're producing widget A this week, and you've got the production floor set up to accommodate widget A, and now all of a sudden you get an expedited order in to produce widget B, then you can quickly reconfigure your network, and you don't have to run conduit and cabling and things to reconnect those assets. You just move them around where you need them, and then you're able to continue operations with minimal disruption. So it gives you some good ROI on efficiencies when there's production changes that need to occur. Connected workers are another great example. Being able to have a worker who's maybe in that petrochemical complex, he gets a work order. It's been difficult to get any kind of coverage in the steel, so they have to walk out to a place where they can get connectivity to get their work order or to sign off on one and get assigned a new one. And they walk back in. Well, we've done some studies, and the industry's done some studies, and it looks like about 20 minutes on average that we were encountering with that. So if you can provide the coverage deep in the steel where the workers are, not only is it a safety, helps worker safety, but it also, you get ROI from the increased efficiencies from being able to sign off on your work. As well as remote expert. That's another great tool. Here, the technician is standing in front of a complex distribution panel, and there's an engineer in the office, and the two of them are connected together in a video session. And let's say the worker is wearing augmented reality or virtual reality glasses, and he's looking at this distribution panel, and the engineer can see everything that the technician sees. And then the engineer can annotate on his screen and say, draw an arrow to a circuit breaker that the worker sees, the technician sees that arrow as he's looking at that circuit breaker. And he says, okay, I'm going to throw this circuit breaker. And then the engineer says, move this jumper from this terminal strip to that terminal strip. And he's drawing arrows to point those out, and the worker sees that, and then he can do it. So you've just now saved the efficiency of that engineer not having to go on site and go assist the worker in that complex task. So we see a lot of those type of support. Remote support is an important use case. Then there's the whole family of autonomous mobile robots or automated guided vehicles. These thrive on their LTE because in 5G, because it's able to accommodate like one single access point with an LTE network. One of our indoor access points can support up to 400 simultaneous users, whereas Wi-Fi, you can get one or two users communicating simultaneously, while 25 to 30 are associated to an access point, thus loading that access point and waiting for their turn to communicate. So when you get a lot of AGVs and autonomous mobile robots running around your facility, that's important, because what we're seeing with deployments of vast numbers of those, and we're seeing more and more of those because they're so efficient, cutting out menial tasks that warehouse workers would have to traditionally perform. And with Wi-Fi, sometimes they'll freeze up when they get to a point where they've encountered a traffic congestion or latency. So they run real smooth on LTE and 5G. And so there's other autonomous vehicle like forklifts and things like that that are moving around facilities, and those do real well as well on these private wireless networks. So those are some of the early adoption use cases that are kind of common across the different industries. But when we take a look at a manufacturing environment, we tend to group these use cases into their different types of functions. So whether it's a connected worker series of use cases or your assets that you're trying to monetize and make sure you have maximum uptime on them, you want to fits in that category, or you're automating the shop floor with robots and other things where you're trying to increase yield or quality control, or it's a digital factory campus and you want to be able to be compliant with regulations, you want that predictable uptime, and you want to be able to validate that predictable uptime. Or maybe you're simply wanting to create a digital factory twin to test your processes out on a software model before deploying them in the production environment. So of all these different use cases, this is like this skyscraper that we're building. We laid the foundation with reliable connectivity that's mobile connectivity, and then we start laying in the different floors of use cases on top of them and just stacking them on top of each other. Many of these use cases, it's often the simple ones that provide the ROI to be able to justify the cost of the expenditure, and then all the other applications get to ride on top of that investment. So we see a lot of that. Simple ones like just being able to have reliable communications in that petrochemical environment for worker safety, or being able to do the remote maintenance or remote expert support. Those are all fairly simple use cases that really thrive on these type of networks. So if we shift our attention now over to the logistics space and see how those use cases, kind of similar family of use cases, fits in the logistics space, we'll take a look at a typical warehouse. So in the warehouse, a lot of times you'll encounter that the automation process is really kind of started in its infancy, and maybe they're doing handheld scanning and tablet operations, looking up, warehouse management system task and order status and things like that from a relatively stationary position. And for that, Wi-Fi can give acceptable results. So you see Wi-Fi deployed in most of these warehouses supporting handheld scanning and tablet operations. But let's say we take that forklift in the center there and start to put technology on it. What we're seeing is that these forklifts become like a technology aggregation point within the warehouse, because the forks themselves on the forklift are now getting smart. They've got HD cameras built into them, barcode scanners, RFID readers, other technology on their scales to be able to weigh things. And maybe there's a tablet connected on there that the driver operates, but due to OSHA requirements, that screen goes blank when the forklift starts to move. But with the smart forks, the communications requirement doesn't cease. So if it lifts up a pallet and the driver starts to move, and maybe it's taking an HD video of the pallet that it wants to send back to post-processing along with the weight and other information on it, it's got to send that up while that forklift's moving. And that forklift moves a lot faster than walking speed. And I've seen this be a problem in warehouses on Wi-Fi, where once that forklift starts moving and it's trying to communicate, it stops until the data throughput just goes to zero until it comes to slows down to a point where it can stop and stay under a particular access point. So this is where private wireless networks really come into play to keep that forklift connected all the time, reliably, no matter where he is in the warehouse or how fast he's moving. along with, autonomous mobile robots that are really taking off in these warehouse environments, moving materials around, or even taking orders that are being picked by humans and placed into an autonomous mobile robot, I call it a autonomous Rubbermaid cart. And they'll place the picking orders, and then that cart will automatically go to the next section of the warehouse and get till it builds an order up and then takes it back to shipping. Well, previously somebody would be picking that order, they'd be pushing that Rubbermaid cart, and they would go walk the whole warehouse picking parts for an order and putting it in that cart, and then pushing the cart to shipping, then getting the empty cart and starting a new order. Well, with these private wireless networks and the autonomous mobile robots, a lot of efficiency gains there. So we see a lot of activity in the warehouse space for being able to enjoy the benefits of these private wireless networks. So when moving outside, providing coverage outside in like a distribution center, there's yard management applications are typically difficult to provide coverage to. Wi-Fi doesn't work in large outdoor spaces very well. And then if coverage for the public network is there, then great. But if not, then what? And so that's where these private wireless networks come into play. So not only can you pick up your yard management applications, but you can pick up remote security cameras around the perimeter, as well as automating the gate and eliminating the security guard and any other IoT sensors that you may pick up off the HVAC equipment on the roof or tank levels or things like that. So there's lots of application in the outdoor space to provide that reliable connectivity. So no discussion is complete without a discussion around cost. And so let's take a look at that. If we take that same 500,000 square foot warehouse and we look at a typical Ethernet cabling exercise, here in this model, you're going to have two methods of access to the network, either Ethernet cable or Wi-Fi. And so to support that, you have to put a number of what we call IDFs, or intermediate distribution frames. And these are cabinets that you deploy throughout the facility where you put access switches in with ports so that you can run Ethernet cables to anywhere within the facility. So Ethernet cable has about 300-foot radius on it. And so in order to pick up all the Wi-Fi access points and power them and provide backhaul for them, as well as any fixed equipment such as a printer or a PC, you would use the Ethernet to do that. So each one of these red boxes is an IDF, and it costs about $25,000 to deploy. There are 9 in this facility, so that was about $225,000 worth of investment for that. You take the circles, which are access points. There were 49 in this facility. The hardware costs about $1,000. Costs about $1,000 to hang it, run a Cat6 cable to the nearest IDF, punch it down, test and turn it up. And so you have about $2,000 per AP. So at 49 of them, that's $98,000. You add those together, it's about $323,000 worth of investment for this 500,000 square foot facility, or about 65 cents per square foot to deploy it. Now, the Wi-Fi that you get here is going to be best effort and not real reliable. And there's a lot of support over its lifetime. Lots of times when applications aren't working, somebody has to go out there and look at it. And Wi-Fi is working like it's supposed to. The equipment is, but the application is not running very well. So you take that and then you contrast it with what a private LTE deployment looks like in that same environment. Here, there's only 10 access points. They cost a bit more to purchase, but they deploy at the same cost as the Wi-Fi access point. And in this model, LTE is reliable enough to be the only network access that you need. So you don't have to run Ethernet cables. So you don't have to put all those IDFs out there and stock them full of switches to get port count to sustain your operations. Here, everything's going to run, all end user equipment will run off the LTE network. And there'll be 3 minimalist IDFs that only have the port count to support the access points that are associated with it. So you can do this at a much lower cost point, about 35 cents a square foot to deploy that. And it ranges depending on the needs, but just like with the Wi-Fi example, it ranges depending on the needs. But this was a real world example and what the cost boiled out to. So to sum it all up, with the private wireless network, it meets the demands of these harsh industrial environments, and it provides the reliability, security, and performance that you need for mission critical applications, and you can do it at a lot lower cost point than you can with Wi-Fi. So with that, I want to thank you for your attention on that, and we'll turn it over to questions and answers at this point.
Hey, terrific. Thank you very much, Mark. A great run through there. I have a ton of questions for you. Before I start firing them away, just a reminder, you can put your question in the box and I'll have a look at it on the back end here. So first question, I think we have to get to Mark. I'll go to Mark first, but then Jerry or Katie, if you want to come in as well and give your perspective from DoubleRadius. Can you talk about spectrum requirements for the base stations / access points? I mean, any mobile technology, we have to kind of drill in on that a little bit. What bands are people deploying in typically, Mark?
So in North America, where where my territory is, in the United States, we use a lot of CBRS band. That's the majority of all of our deployments. Nokia has a global presence, and we broker spectrum for our customers all across the globe. So no matter where the country or region that you're operating in, we can provide spectrum with our solution. So primarily in North America, it's CBRS, but people will run these LTE networks on the same Uni 3 band that Wi-Fi operates in. We see a lot of that in global deployments. Nokia has exclusive access to certain bands within certain regions. And so, again, our solution comes with the spectrum as part of the solution.
Sure. Okay, and just for a bit of color on the CBRS, interesting that you say it's becoming the dominant band. Is it typically the GAA or the PAL, priority access licenses or some sort of mixture?
So, we sell to all kinds of different customers. We prefer to work through the partner model, such as DoubleRadius. And most of the end user enterprises are just deploying CBRS. And if there is not a PAL licensee operating within the power contours of their facility, they have access to those channels in addition to the GAA channels. So, a 20 meg channel on LTE provides an awful lot of capacity and performance. And so we are deploying this across the board on these CBRS channels, and GAA, seems to be fitting the need for most of these businesses.
Okay, yeah, I would echo what Mark says. Oh,
please go ahead, Katie.
So I would echo what Mark says. I think we see both PAL and GAA, and on our end, it's probably more GAA than PAL operators for CBRS. And we also do see, so CBRS is probably 90% for the private wireless, but there are some operators who have the EBS band 41 spectrum as well that we will see for some deployments. But that's a much smaller portion. CBRS definitely takes the cake on that.
Mm-hmm, mm-hmm. And just a quick one, Mark, a clarification. You talked about a 20 megahertz channel giving a lot of capacity. In your cost model that you presented right at the end there, obviously you're showing many fewer devices for the deployment. Do you measure up in terms of capacity with the LTE system? Wi-Fi is using has a lot of capacity as well.
Right. So with the same 20 meg channel, the physics are the same for either Wi-Fi or for LTE or 5G. And so they're very similar in the amount of bandwidth that they can deliver per megahertz of channel width. So, that's not really a differentiating factor. You go wider bandwidth, and perhaps there's some changes to the equation. But for the typical enterprise deployment with 20 meg or even 40 meg, you get the performance that you need, from that for most of the use cases that we're seeing.
Yeah. Okay, then another question, first to Mark and then Katie, Jerry, if you want. What's the sort of typical profile of the customer here? Are these generally, very high-end, technology-savvy companies with, a big team? That's the history of private mobile. Has it started to kind of work into more the mid-market, or I don't know, just get a feel for, is private mobile? It has been a high-end technology. Is it working out of that into the mid-market, would you say?
Yes, it is. And that's where our Nokia digital automation cloud technology comes into play. So we take the complexity of the 5G and LTE networks and provide a software wrapper around it to manage it and deploy it. And I like to say that if you can deploy an enterprise Wi-Fi network, you can deploy one of these NDAC or Nokia digital automation cloud networks, because the architecture is very similar. It's very familiar to the enterprise architect who's been deploying Wi-Fi all these years. So that edge controller or edge server looks like a Wi-Fi controller, and access points look like access points. So the complexity has been taken out of it. So traditionally, when you deployed a full, IMS core and things on-prem in the traditional, cellular type application, then yes, that's pretty complex, and you have to have specialized skill set to run it. But what we've done is taken that model and condensed it down to where it can be managed through that portal, and it looks a lot like Wi-Fi. So we're seeing great adoption for that all the way down to small enterprise. So, this is going across the board.
Okay. Katie from DoubleRadius and Jerry, if you'd like, do you want to comment on this, the size of the deployment and the type of enterprise question?
Gabriel, to me, it is really the opportunity for the smaller organizations and the less sophisticated organizations to take advantage of the greater technology. I think either working through us where we can walk you through that process, or taking advantage of the simplicity of the Nokia system. There really is a benefit that hasn't happened in the past, and especially as you look in this small to medium market. I think from the large market down to medium, people think, that's too complex for us. And even in the small market looking up, they just don't know the questions to ask. And I think in both of those situations, our partnership works really well, and that we have the staff to be able to walk you through the questions you have to make you feel comfortable through that installation and deployment process, and really in the design of that system as well.
Yeah. Jerry, can you get underway then with a handful of, I'll call them access points just for simplicity? Is that, or, are you talking bigger deals, or is there a kind of a place you can get started?
Oh, no, you can start very small, and whether that's just a part of your organization, or it's a beginning of a plan to do a proof of concept, absolutely, you can start small and move up and see how that performance is benefiting just a little piece, and then so you get your feet wet to get comfortable with the change in technology.
Mm-hmm. Okay, stay with you, Jerry, for this one, but we'll go to Mark and Katie. What about devices then, Jerry? You want to do a small program. You're doing a few access points. You're growing it. You've got a good set of use cases, but you really need access to these devices that Mark talked about: the modules, the dongles, the routers, the cameras, the body, worker safety sensors, the myriad number of devices you might need for your use cases. From the customer side, how do you get access to these? How do you know the devices you might see on a marketplace are going to work with your system and are approved? And it's can be quite daunting.
Well, I think that's the advantage of working with a distributor that has partners like Nokia. We have a large selection of master distributor manufacturers that we work with to be able to help kind of bridge the gap of knowledge and to be able to say, here's where we can get this, here's our partner you can use. We also have relationships with consulting companies and engineering companies that can provide that knowledge as well. We really manage that end to end from our perspective. And then when it gets too complex for us, we rely on our partnership with Nokia to provide much of the knowledge like Mark reviewed today. It's where that bridge to be able to do that, where it's sometimes too simple or sometimes too complex. And in those cases, we can provide the opportunity to buy some of those additional gadgets, as you would say, or we can point you out to the place you need to be able to work with to get those additional pieces of equipment.
Mm-hmm, mm-hmm. Okay, good stuff. Mark, you want to add on that, or if not, I have another couple of questions for you here.
Well, all I would add to that is that the device ecosystem across CBRS in North America is pretty mature at this point for LTE connection. And so we're seeing a lot more LTE than, say, 5G. Well, that will change as the device ecosystem catches up. But yes, devices are readily available and easily connected to these networks.
Yeah. The related question, comment on 5G is interesting. The related question is, I think you've sort of answered it, but maybe you could go a little bit more specific. The question is, who manages the SIMs in these examples? So is this the customer managing it, or is this a Nokia partner, a DoubleRadius partner? This is all your authentication, really, and subscriber profiles and all this sort of thing. Is that in the package, or is that you got some third party managing your authentication?
So with a Nokia solution, it's all in-house as part of that end-to-end solution. SIMs come included. So whether you work through your distributor partner, such as DoubleRadius, to manage that for you, or if you're comfortable enough doing that, it's part of that portal. You can do that yourself. But we see that across the board. Some customers are just customers are more comfortable allowing their distributor partner, to provide those extra services for them to do things like that. But others are comfortable with running the software through the portal and they can do it themselves. So we give the flexibility to match the solution to the customer's comfort level.
Yeah. We talked a bit in your presentation of the sort of deployment and ops model in many ways is quite similar to Wi-Fi with private mobile. Do the customers need to know like cellular protocols? And we're talking about SIMs there and all that goes with that. Do they need to know that kind of thing, or is it are the systems mature enough now that you can almost hide the cellular complexities? Isn't quite the word I want, but all the cellular specific stuff that you might not come across.
So we're finding that enterprise customers are, especially like in the networking group, the wireless team, that they're quickly adopting this because they say, my skills actually match this. I'm able to do all these different things. So we see, great adoption from the wireless teams on these enterprise network organizations. And so, it's a little bit different. You got to understand that you got to put a SIM card in it. Well, that's simple enough to understand. When you're looking at your test application, you're going to learn some new terms and things. You're going to see some things that shock you, like with Wi-Fi, you design for, say, neg 62. It starts running out of steam at neg 69 of, received signals indication. Then you'll see on LTE that you're starting out with more power to begin with, but it continues to operate awesomely up to all the way down to neg 139. And so, from the wireless experts in these enterprise organizations, that just blows them away because you've got, 60 to 80 dB more headroom for being able to penetrate obstacles and things that typically stop a signal. So yeah, once they see it, we like to go on site and do a demo, and a little one-day demo. And once we do that and show people how this stuff works, how easy it is to set up and deploy, we can be on site, set something up in 20 minutes and be up and running and giving them devices, letting them run all over the place. And we've had great success doing that.
Terrific. That actually brings us pretty much to the top of the hour here. So I'm going to close out the call first of all by thanking Mark Brandt from Nokia. Thank you, Mark. Great to have you with us.
Welcome, and thank you for the opportunity to present our solutions.
Good stuff. Thank you. And Jerry Ford from DoubleRadius. Thank you, Jerry.
Thank you. It's been great.
And Katie Hale as well, also from DoubleRadius. Thanks, Katie.
Thanks, Gabriel. It's great being here. Thanks.
Cheers. Now, there's a whole bunch of questions we didn't get to. I'm going to ask the group to have a look through them, and where appropriate, they're probably not going to get back to you if you're a competitor or something like that. But where appropriate, see if they can follow up with you. Certainly, there's a couple around some very high performance applications that probably weren't for today. But if they can, they'll be in touch after the webinar. With that, thanks everybody for participating, for attending and submitting questions. Thank you very much, and goodbye.